3,700 individual pieces, 16 cylinders, 64 valves, 4 camshafts, 2 cylinder heads, 4 turbochargers, 7 radiators for the engine, not counting other radiators such as the one for the transmission or the differential. Its exact displacement is 7,993 cubic centimeters, almost 8 liters, or 488 cubic inches. And with all this, the first version generated 1,001 horsepower, and moving to the Chiron version, the power exceeded 1,600 horsepower. But let's take a closer look on how this machine works and the engineering challenges it had to overcome. Bugatti is a French company under the wing of the Volkswagen Group, and in 2005 it presented the Veyron. However, we have to go back to 1997 when its design began. Ferdinand Porsche's grandson, Ferdinand Piëch, VW leader, was riding the Japanese bullet train and told the engineering chief that he needed a car with more than 1,000 horsepower. He took the closest paper to him and began to write. To develop such a level, they estimated that they would need a 9-liter, 18-cylinder engine, which suggested the use of a V-engine. The issue is that it would still be too long anyway, impossible to put in a car, and to solve it, they decided to use the Golf VR6 engine. The VR engine means that its cylinders are packed in a line with very little angle of inclination and offset to the center, resulting in a very compact engine. As against, the efficiency decreases slightly. Although this is easily compensated with greater displacement within the same volume of a V engine. Now, the next step is to duplicate the VR6 block and put it at 90 degrees to the center. Finally, it's stretched to 18 cylinders. The problem is that 18 cylinders in W seemed very long, therefore, instead of going in line, it was decided to go radial. VR6 blocks were placed every 60 degrees, first one, then another, and finally the third block. In this way, the 18 cylinders are reached in a compact way. With the sketch in the paper envelope, they both went to the offices and continued working with the entire team. The engine was built, but the problem was that there was no room for the turbos. Also, central cylinder head tends to overheat since it's surrounded by 2 cylinder heads. What's more, studies on the shape of the combustion and how it progresses along the cylinder have shown that for an engine that rotates at approximately 6,500 RPM, the ideal size is 0.5 liters per cylinder. It was also discovered that 8 liters would be enough to exceed 1,000 horsepower, abandoning the initial idea of the 3-block W18 and moving on to the lengthened W16. These two VR8 engines with 15 degrees between banks are joined at 90 degrees. The block is made of aluminum and measures 28 inches long. It is shorter than a V12 and weighs only 1,000 pounds fully armed. The ultra-advanced alloy for that time allows continuous full-power operation without fatigue, and unlike a race engine, the W16 is designed to last 250,000 miles, no matter how much punishment it takes. The Veyron with the highest mileage currently in existence is from 2005 and has only 45,000 miles. That means it travels approximately 2,500 miles per year. The pistons have an 86 by 86 mm diameter per stroke, giving a square engine of medium revs, balanced between power and torque. It has a 9.0 to 1 compression ratio, 1,001 horsepower, and 920 pound-foot. Its piston with its angled upper face is easily noticeable because it's a W engine. It also has milled valve seats to allow a longer opening time. In the center is a slight depression to complement the hemispherical combustion chamber. The cylinder head has a large number of bolts to hold it to the block. It is made of aluminum and has an asymmetric pent roof chamber. One line of cylinders has the valves at one angle and the other line at another angle. This is to use half of the camshafts, but as a consequence, the valves must point towards it, and that's why they're different. The valves have a stem of different length depending on the bank of cylinders. Bugatti claims that its exhaust valves are made from a secret alloy and can withstand continuous use at 1,000 degrees Celsius. To avoid having to regulate the 64 valves, which would be an almost infinite task, hydraulic lifters are used. Oil pressure keeps the lifters full, compensating for temperature variations and giving noise-free operation like a streetcar. It also compensates for the wear suffered by the valve and its seat in each revolution, making the system maintenance-free. As a consequence, hydraulic tappets limit the number of revolutions to less than 8,000. Although the Veyron's rev limit is 6,500 RPM, so there's no problem. If the engine were to spin faster, the tappets would unload and the valves would open less, reducing power. A normal engine drives the valves directly with the camshaft. This is not very good since a lot of friction and wear occurs. In fact, the valve trains are the main place where more friction occurs in an engine, wasting horsepower. Bugatti and all modern cars made today use rocker arms with intermediate rollers, thus reducing friction. The camshaft does not suffer wear. Considering that 64 valves are used, the energy savings are very noticeable. Moving now to the turbos, each one is powered by 4 cylinders. The first version of the W16 that generated 1,001 horsepower and then 1,200 horsepower by the end of its manufacture used 4 equal turbos with pneumatic wastegates. The wastegates are responsible for controlling the turbo pressure to 18 psi, but being a pneumatic system, it is not very precise. Notwithstanding, it fulfills its function perfectly, and when 18 psi is reached, the valve opens, preventing the exhaust gases from going through the turbo. Turbine speed drops. If the pressure drops, the valve closes again, speeding up the turbine. Later, with the appearance of the Chiron, the 4 twin turbos were replaced by 2 small and 2 large. The actuators were replaced by electronic modules and controlled by computer. With this new technology, the turbo bypass gates are perfectly controlled in all driving conditions. This sequential turbo setup provides maximum boost pressure from 2,000 RPM to 6,000. The turbos blow a total of 3,700 gallons of air per minute. As for the fuel system, all the cars use direct current pumps that always rotate at the same speed with a mechanical pressure regulator. The Veyron uses 2 3-phase alternating current pumps controlled by a variable frequency drive, being more precise and varying its speed as demanded by the engine. The location of the tank is above the gearbox and it has this inverted U shape. There are pipes that go to the other side so that the pumps suck evenly. Then we have 2 injectors per cylinder, one big and one small. When the car is on low power, it only uses one. The second injector kicks in when needed. If a single large injector were used, the engine would have trouble controlling the dosage at low speed. Let's not forget that the Bugatti is also a car designed for daily use that complies with environmental regulations and uses catalytic converters. The Veyron's fuel tank holds 100 liters or 26 gallons, and in just 12 minutes at 250 miles per hour, it's completely empty. That is to say, less than 3 miles per gallon. In the case of the Chiron, which has 1,500 horsepower, the 26-gallon tank would last less than 7 minutes at 310 miles per hour. Although by computer, it is limited to only 260 miles per hour. This is because the tires do not resist. Under normal conditions, this engine registers about 10 miles per gallon, while the average for a normal car is 30 miles per gallon. In the upper part of the engine, we find one water cooler per bank. Basically, it's an intercooler where hot air from the turbo passes inside and instead of fresh air, cold water is used to cool. This cold water is then taken to other radiators and strategic air intakes to cool it. The camshaft's timing system is made up of a chain that goes up toward a balance axis, and then from this, 2 new chains come out towards each cylinder head. The camshafts have a hydraulic variation system to change the opening time. Each of the 16 iridium spark plugs is connected to a single electronic coil that gives it the high voltage to ignite under turbo pressure. The Bugatti's thermal efficiency is 33%. That means the 1,000 horsepower Veyron puts out another 2,000 horsepower in heat. This heat is removed by the 3 front water radiators using 40 liters or 10 gallons of antifreeze, although the main heat generated leaves through the exhaust gases. Basically, the 2,000 horsepower of thermal power is equivalent to 700 electric stoves of 2,000 watts. The first time the engine power was measured, the 2,000 horsepower coming out of the ventilation ducts overheated to such an extent that the factory fire alarm was activated. Other special technologies such as active aerodynamics are used to prevent the car from taking off when running at top speed. Aerodynamic brakes like airplanes are also used. In fact, this car is faster than several planes. It achieves 0.4 Mach. Finally, the engine is connected to a 7-speed dual-clutch DSG gearbox. One axis has the odd gears, and the other axis has the even ones. The gearbox has an oil cooler. The differentials also have an oil cooler and are of the Haldex type. The Bugatti CEO already confirmed that this W16 is the last of its kind. 99 units of the new Mistral will be produced, and then the next car will have a smaller engine and will be helped by electric motors. But despite this, it will be faster. Did you enjoy the video? Leave your like and a super thanks, that helps me a lot. Also, comment what you think of this Colossus and what other engine or topic you'd like us to analyze. My name is Francis and I'm Repman22. See you next time.